Outstanding intro. That was actually really great. Uh, talk is over. Thank you. All the major points. Um, so thanks for having me. I am, as previously mentioned, a former staff level software engineer, and I left industry. I left to get away with it, is how I talk about it. There's things I wanted to do that maybe didn't necessarily make one company money, but that I hoped, fingers crossed, would be good for the world. So I'm going to sort of be talking about my journey, leaving decent money and a cushy job for a PhD, which is not cushy and there is no money. Don't do a PhD. I will mostly be talking about good today and lightly touching on evil, just a sprinkling of evil. And hopefully at the end of this, if any of you are really curious about working on projects or even questioning the work you're doing, start a conversation, whether with me or with the people in this room. Especially if you're early in your career and you're unsure of whether or not what you're doing is good or what you really want. I think we all wrestle with these questions all the time. I'm very happy with the decisions that I made. And I think conversations are really how I got to the point where I'm happy. Not necessarily making the right decisions, but talking it through with people. And believe me, I don't make the right decisions. So to dig in, I'm a tool maker. When I started my PhD, they give you a class that's kind of like intro to doing research. How should you think about doing a PhD? And one of the first things that they tell you is to frame your research as if there is a dragon and you are the hero with a sword and only you know how to slay the dragon. And that just didn't ring true for me. I actually like to build the sword for the hero, for that main character. And so I've been thinking about myself ever since then as more like a blacksmith, I guess, or like a Merlin maybe. Merlin's cool, so, but I don't know if I'm cool enough to be Merlin yet. But yeah, at least a blacksmith. I make tools, and I hopefully empower sort of main characters out there to go do their thing, slay their dragons. But making tools has taught me a lot. It frames how you think about the work. You're not trying to solve problems. You're trying to create new opportunities, new directions, new possibilities for other people. And it requires you to have relationships with people in order to make good tools. So I'll unpack that a little bit. But that being said, I will get a little philosophical. I am right, it's a PhD, so it's a philosophy doctore or whatever it is in Latin, I don't know. But it's like philosophy degree, that's what it is. So I do want to think about tools and other things just a little bit and hopefully give you a very short intro today to how I think about tools. Technology, different than tools. Tools are sort of defined as, or I define it as just technology in use. That is when something becomes a tool. And chairs, I love this quote. There's this little project. It's funny, this quote is from LinkedIn, but the project's very good. But it's a LinkedIn quote. I'm sorry. I'm sorry. But the quote is about technology and how the creators of technology shape us through our use of their technology. And so a chair asks you to sit still, sit face forward, behave. These chairs you're sitting in right now don't allow you to turn to anyone you're next to and speak to them. You have to turn your body against the chair. You have to fight the technology to do certain things. So thinking about how tools reify and functionalize our values, that's a fancy word, reify. It just means to make real something abstract, to bring that abstract concept into reality. And that's what tools do. Tools bring the intentions of the tool maker into the world. So when I say our values, of course, I mean whoever made that tool, not like the user of the tool, but often the maker. So I'll give a brief video of, and hopefully there is no sound because actually I want to talk over it. I'll give a brief video of what I mean. I work making data visualization tools. And specifically, I'm hoping to have more accessible outcomes. So I hope to empower developers and designers to think about accessibility, which means to think about people with disabilities using their charts and graphs and so on. And one example of somebody who might have a disability would be somebody who's blind. So if you're visualizing data, but you want somebody who is blind to interact with your data, what people will do who are blind is they use a device called a screen reader, and it navigates content. So unlike if I move my little mouse here, this is a pointer device. Pointer devices are direct. Wherever they are and wherever you click, something happens. But screen readers navigate. So Let's have this start the navigation here. So there's a big focus indicator. The mouse will be following my focus indicator here. So if it's harder to see the focus indicator is this big dark outline, and underneath is the caption or the text that's being shown is what the screen reader's reading out. So the screen reader's navigating across these headings, and now it makes it into a data visualization. And I'm going to pause it here really quick because this is when it gets bad. If you're blind and you're navigating a bunch of charts, so if you look at these charts, these are economic, these are how Americans respond to economic policy. So specifically Trump's economic plan. These came out earlier. These are charts by the folks at the Financial Times. And if you look at them with your eyes, you'll see at the very end of all of these charts, something quite dramatic happens in each of them. They either spike up or spike down. Bad, dramatic. That's the point of the story. Now, somebody with a screen reader this is very painful. It's 40 years of data, and each navigation, each time you press forward, it is a quarter. It will take you a long time to even get to the data point at the end, but if you hear the data point, I highly doubt you're going to understand what's happening. It's very hard. What could solve this is simply a short description or something else, or maybe just rethinking how we provide access here so that it's more meaningful or useful, and so on. But the point I want to make isn't just that this is a bad screen reader experience, but that the people who made these charts could not control this. They did not design this experience. This is a tool called Flourish. And the people are at Financial Times using this tool to visualize. When they visualize their data, they get this out of the box. They get this accessibility out of the box. They didn't really know that this experience would happen for their users who use screen readers. They didn't know that some really annoying person who checks data visualizations with screen readers would go poking around their stuff and find this. I'm actually in conversation with the folks at Flourish, and they are lovely, so I just want to say this is absolutely no shade at them. They're wonderful, and they are, of course, working on this problem, making better tools. But tools serve the intentions or the forgetfulness of the lack of intention of their creators. Another thing I really want to just stress in the talk today is that I'm going to be talking about just the ethics of tools and how they participate in society, and actually how the whole world will come together to create a simple tool. So I went and looked, and I wondered, what does it take to make a hammer in Australia? Bad news, spoiler alert, apparently Australia actually imports most of their woodworking tools and things like hammers, so they don't make them here in Australia. But that actually still participates in my point, which is that society, international policy, international trade, all of these things participate in things that are as simple as a tool. There's a phrase that irks me to no end, which is that AI is just a tool. It only matters how you swing it, as if a hammer is only a tool and it only matters how you swing it. That is absolutely not true. The whole world comes together to create something as simple as a hammer. Here in Australia, at Karijini National Park, I probably did not say that quite so well, in Western Australia, it's gorgeous, it's beautiful. You might notice two really stark colors here. I love this bluish color, but there's this reddish color too. Does anybody know where I'm going with this? What is this? Anybody play Minecraft? This is iron. That red is iron. And in the 90s, the state decided to carve out part of the park and turn it into an iron mine so they could mine iron. Now, policy participates in the production of tools, decision-making by humans, sometimes not always by us, but other humans, ends up producing something like a hammer, although apparently it's not actually a hammer that's probably being used for the iron here. I don't know what they make with this iron. But this is just an example about how something that was intended to be preserved for beauty and all kinds of other things has now had a piece of it carved out, no longer for preservation, but for production of iron. And not that producing iron is inherently bad, but that we should all be thinking about the iron mines behind the tools that we use. What does it take for us to use any simple tool? Where are the data centers for our AI? And so on. Okay, so moving on, keep these two things in mind. What are the iron mines? What are the chairs? Okay. I'm really going to be talking about human-tool interaction and the role of the tool maker. And I just want to say people with disabilities, they deserve to participate in politics. They deserve to make informed decisions, and they deserve to analyze data quickly and efficiently. This is the work that I do. Most of my work, most of my tool making is here. It's trying to include people with disabilities in participation in society. And I do this by, fingers crossed, building better tools. But of course, as I've already said, good tools aren't enough. All of society kind of has to come together to even make tools effective, to even create tools, bring them into being. So what I'm about to show you is a very simplified version of how I think about my work that sort of does not include these big societal questions. But really, creators use tools to make things. And as time goes on, we get more and more things. It's a very simple model. Now, anybody in the room want to guess? If I'm just talking about websites, what percentage of websites that we can automatically detect, so if we automatically run some tests for accessibility on websites, say the top 1 million websites, maybe this is a real actual study that happens, it is. What percentage? Anybody have a guess? Oh, actually, we'll do a raise of hands. Okay, everybody hands up because it's between 0 and 25% of websites contain at least one accessibility error that will exclude somebody with a disability. It's between 0 and 25, so everybody should have their hand up. That means at least nothing. Okay, so keep your hand up. Do you think between 26 and 50% of websites contain at least one major accessibility error that excludes somebody with a disability? At least up to half? Okay, nice. Most hands are still up. Okay, 51 to 75, 3/4. More hands went up. That's really funny. It's getting worse. Okay, what about 76 to 95? Even more hands. That's so funny. Okay, wait, did I pose this wrong? Okay, yeah, instructions hard, sorry. Okay. It's actually 97 to 99% of websites contain at least one major accessibility barrier that it will exclude somebody with a disability. And these are only tests we can do automatically. So actually the picture's probably even worse. It's probably like basically all websites. Something about them's probably pretty inaccessible. That's not great. So I set out, because my PhD, I wanted to investigate this. And no offense to Visa. Visa, my work was awesome, and I'll even unpack some of it. But they are not necessarily motivated to do large-scale change. They want to make Visa money. They're a business. But I wanted to ask, can we just build better tools that reduce inaccessibility across the large ecosystem of data visualization tools and ways people experience data, and so on and so forth? So that's how I think about my work. And again, it's very optimistic. So category 1 of 4. See how I'm doing on time? Yes, perfectly on time. Okay, tools for scale. So this category of tools, I will have 4 categories I talk about today. Category 1 is the most common. And in fact, most tools we build in industry are simply this kind of tool. Make more money, make it faster, build, scale, go big, or go home. And there's nothing necessarily inherently wrong about tools for scale. It's just one type of tool. So it's only category 1 of 4 today. So it's like 101. This is the intro class of tools. Tools are great because they empower us to build things faster. I think this is the major justification I hear for using something like AI. It empowers me to do X, Y, Z much more quickly than I could. That's great. That's fine. I do this work too, just not necessarily always with AI, but I will talk about how I've done this work. So at Visa, I was at Visa working on a data visualization library. Staff level engineer, so I was leading a few of the efforts. One of them was on accessibility. Also did motion design, and I was also really interested in performance and some other stuff. But at Visa, they care about scale. I don't think it's shown here. Oh, awesome. Yes. Okay. In a year, how many transactions do you think Visa, the card company, processes? Anybody think 100 million to a billion? Bajillion? It's a lot. It's 200 billion. So that's a ton. It's really, really, really quite a lot. And they have what they call 5 nines of a service level agreement. So that level of uptime is actually quite absurd. It means that 99.999% of the time, there's uptime when you use your Visa card. Most of you will probably never have a network-related error, some model-related error when you try and buy something with your Visa card over the course of your life. You would have to, what is that, purchase 100,000 things or something? I don't know. That's not actually how the math works. It's really about redundancy and a bunch of other stuff. But they have a lot of data. And speed and scale is very important. And I worked in tandem with the data teams, building data products, working on visualization. If you really want some like interesting numbers, 5 nines of downtime means like in a whole year, you might only have 5 minutes where you have some kind of network failure or things not working out. Oh, nice. For me? Yeah.
Any better?
Okay, thank you. I appreciate that. I am actually normally quite loud. That's funny. I don't mind being louder. Oh, I already revealed the 233 here. Wow, didn't even practice these slides. No, I'm kidding. So I worked on what's called Visa Chart components. It was actually their first open source project. It's a whole component library of data visualizations. We really cared about speed and scale, not just speed and scale when you use the visualizations. Again, it's not just about use, but speed and scale about the people who build. We wanted people to build fast, consistent products that are super accessible. So we wanted to provide a lot of accessibility out of the box. And remember, spoiler, I've already spoiled it. Some out of the box accessibility isn't good from that video I showed earlier. I'm not going to be showing the bad stuff here, though. I want to talk about the cool things I did. So obviously we had screen reader navigation. This is going to be, I'm using a screen reader. I'm navigating into a chart. And we have this like group level navigation. You can go, here I'm on AC, the line, I'm navigating across each data point. This is already better than the Flourish one because I can skip over the whole line before I go into it. I don't have to go one data point at a time. I can check out the line first. We also did text treatment, so a bunch of automatic label collision. We used this algorithm who's by the guy who's actually my advisor right now, Dominic Moritz. They have this great algorithm for making sure labels don't overlap, but also they're positioned really well. It's a very hard problem, especially when you have a lot of data points to do this automatically. So glad somebody else smart figured it out. This is kind of what it would look like to create a bitmap for calculating collision for something like a pie chart. We worked on color contrast algorithms. So here's some, it's like a scatter plot. It's not a great design, but it demonstrates my point that I'm going to talk about. Contrast is really important because folks who are low vision may have trouble differentiating between colors or seeing something on its backgrounds. This color, if a developer, say, passes in a color that is nearly white, this is 1% blue saturation, 99% brightness, so it's basically white, but a teeny bit blue. What we actually do is we always try and maintain the hue, but we darken the color until it passes contrast requirements for accessibility requirements. And then we just add that as an outline to any object with a failing color. So developers like literally can try and make bad choices, and we still are like, you fool. This is how you should be doing it. So we do this with all kinds of stuff, actually. So they don't even think about coloring the text of their that's used in their visualization. So like if you zoom in on the text, if you have a dark background, we make the text light. Light background, the text is dark. We also add outlines to all of our text because it makes it easier to read. These are all things that if you study accessibility, you read a bunch of standards, you learn these are the good things to do. And we wanted people to just, who don't even know a thing about accessibility, to get this stuff because they can build faster when they don't have to all be experts in accessibility. We thought about interaction state. So all of our charts and graphs and so on, you can like click them, you can navigate into them, you can, select them with screen readers and so on. And so you might have a default state, either a light or dark fill. If you hover them, we add this dashed outline. If you focus them with a screen reader, it gets this very dark outline as well as the hover state. If you select it, we thicken the outline. If it's selected and hovered, it's thick and dashed. And then, of course, if you focus something that is selected, it gets that thicker outline with a dash as well. And we don't really want people to have to think about this. This is complex stuff. If you've ever messed around with design systems, if any of you are design system engineers, there are people who obsess for years about the perfect button and how to communicate state with a button. So we wanted to do something like that for people who used our charts. So that somebody could just build a visualization, put it in a product, build dashboards, and not have to think about like, is a bar in a bar chart a button and how you design that well. We supported over 200 data products at vSun, about 2,000 engineers. So this was definitely about speed and scale for them. And I literally did spend weeks on that border design. I love the one pixel in. This is just me bragging about something that makes me so happy. Like, that's actually really hard to do. Anyway, thank you. So redundant encoding, there's also ways, a lot of people with disabilities, those with photosensitivity in particular, actually use their computers on grayscale or reduced saturation. And so you don't want to use color alone to communicate information. So if you're using blue for something that's meaningful, you want the ability for people to turn on redundant encoding or have that available. So we have textures for fills. And yes, I also spent weeks making sure you get that 1 pixel border of clearance on the inside, which feels really nice to me. Is that a good design decision? I don't know. It's design tool making for good, evil, and also just literally what I think is cool. And then of course we have redundant encoding for shapes and then dash patterns for lines and so on. And one point I want to make is if you're at a company and you only ever build tools for scale, you should sometimes also build tools for fun for yourself, for your own sanity. Tool making in companies, I don't know, sometimes gets boring. So I had fun. I also thought about how would we do numerical fills? This is probably bad design. I don't know if it's evil, but nobody's really done this. And actually, since I shared this, some people in the mapping community started doing patterns and stuff on maps for geovisualization encoding, and they are probably just better designers than me because it looked really good. So I was flattered that they used this idea. But this idea is like, we're using angle and the thickness of a dash pattern in a line. And so it's like -1 to +1 here. So the line itself kind of rotates. It was a fun experiment. So takeaway from this, maybe just still have fun. Okay. Does anybody know why I'm going to talk about why automation might not be bad? Spoiler, it's maybe related to the video earlier, but it's not just that people who use our tools don't have power. Yeah, it's already baked in. Yes. And why is that bad? Why is it bad to have something baked in? Oh no, gripe. Yeah, bad. What's a bad thing? It's not evil, but why is it bad? They don't think about it. Automation shifts our brain. Lots of studies on this over time. This one's actually about how using LLMs literally activates fewer neurons, fewer pathways. It significantly shapes how we remember the work we've done. I remember making a pixel difference 5, 6, 7 years ago now to make those patterns really beautiful. But when we create things with tools, with automation, we think less about it. We feel less of a sense of ownership. We feel less of being tool makers ourselves. And so think also about what pieces of your soul are you giving to automation when you build. Sometimes it's worth it. We want automation, of course. We want scale. We have problems of scale and we need to solve. But at the same time, be a little bit selfish and think about the things which neural pathways in your brain do you want to form? What thoughts do you want to have of your own? What things you really want to chew on? And this matters actually in dev support. We did work because it turns out developers, if you give them only accessibility out of the box, they just do whatever you gave them. We would give them all these levers to pull. Okay, well, you can customize this part of thing. You can change this. You have the power to do this. And they wouldn't do any of it actually, because they'd just be like, oh, that's stuff I don't know. Ship it. It's probably good. The smart guys designed that button, so the button guys are on it. So we added validation intentionally to annoy developers, because you know what developers love is a console. You know what developers don't love is a console that's red telling them they did bad stuff. So we actually intentionally introduced hassles so that they would stop and think about, why did you just let this be? Or why did you send this in the way that you did? And I love this quote by Hayao Miyazaki. This is art drawn by a real artist. In response to generative art, they just wanted to draw somebody who is also an artist. And there's this beautiful quote that Miyazaki has, which is, if life's hassles disappeared, you'd want them back. Life isn't always about automating all hassles away. Some hassles are good. And so some of the work that we do is actually thinking about which areas do we really want to struggle with and grow our brains on, evolve ourselves selfishly. So that leads me to the next type of tool. So from tools of scale to tools of thinking, helping people evaluate critically. And this does mean introducing a little bit of pain into people's work. Maybe evil for the sake of good. I don't know how you want to think about that. But the big question I had is, how do people actually find and evaluate accessibility barriers in interactive visualizations? This was the first real researchy project of my PhD. The you here being tool users, practitioners, people who visualize data for other people. How do they find and evaluate accessibility barriers? It's a big question. I don't know. We don't know how people do this work. They're bad at it, spoiler. So what we did is we made a workbook of tests and tools and procedures, principles, and so on to try and guide people through this process. And it's a lot. It's quite a lot of work. We actually intended it to be very highly detailed for the people who kind of wanted that pain, wanted those neural pathways to grow. Tools for people who want to dig deep is an underappreciated type of tool making. Not all tools need to be the simplest, easiest things to use. Some people, have you ever seen older interfaces of like, actually Photoshop is a great idea, or a great example I've used in other talks about, if you were to show like a Victorian child Photoshop interface, they would probably die instantly because there's so much happening. But if you're really skilled with Photoshop, it's actually beautiful because every button means something to you. So tools for people willing to dig deep actually is an important type of tool, and it doesn't necessarily speed you up. Sometimes it intentionally slows you down when it matters. So let's poke at this map from CNN. I've talked to the folks at CNN. I've used this map for years, so that's why I keep using it, because they know that I talk about this. So I'm not just roasting random people. We'll just use Chartability to just go over color. I already mentioned earlier, high contrast is important. You could have automated tools that automate contrast, but in a lot of designerly roles, you actually want much more control over color. You don't always want stuff to be automatic. So in those cases, you need to understand what contrast is. Low contrast is this lighter bar on this bluish background I have, and it's pretty hard to see. And then higher contrast is the darker stuff on this exact same background, and those are easier to see. And so contrast is really just the difference between one and another color. There's some really simple algorithms for calculating, tons of tools you can use, where you just input one color, input the other, you get a score between them. That's how much contrast those two colors have against each other. And knowing this allows you to design quite a lot. So in this case, you would just input the color for the text, the color for the background. The score is 2.95 to 1. That fails. Actually, this is against a white background, so it's worse against my slides. And you would need to bump it up. So any large text needs 3 to 1 or higher, and the geometries are really bad. They need to have, they also need to have 3 to 1 or higher, but they were lighter. So in the case of the map, that's just explaining what contrast is. You just use a color dropper or maybe some code or maybe whatever. Look at your palettes you're using and compare the colors in some tools. And for this one, actually, the contrast is pretty good. Only where Trump, text for Trump, which is red, is used, it fails. And actually, it's great contrast everywhere else. So 6 instances here. Can we fix it? Chartability does not just tell you, here's the fix. Remember, it's a tool for thinking. So it suggests, if you're thinking about color, put stuff in grayscale. Because contrast is actually a measure of luminance. It's the difference between lightness in stuff. And so, if you put it in grayscale, you can actually see for yourself what the luminance difference is. Does anybody know? You're great. So I will say, not you. Does anyone else know? Thank you. Anybody else have a guess where the problem is that I'm about to talk about? What's bad? Evil. Yeah. The CNN projector. Ah, excellent. Very good. Oh my gosh, I'm getting feedback.
There are different colors.
That's very funny. Okay. Sorry, I had to kill the feedback. What was that? Different colors in the map?
Like there's at least 3 different colors.
There are 2. There's
Yeah,
2.
like 2
And then the lines. Yeah. That's not the problem. The CNN one is what I was asking about. The problem is the bar at the top. The most important part of the whole thing is being able to tell who's crossed the middle and won. And it's very hard to see between these 2 colors. And really, Chartability just says look for stuff like this and maybe just add little dividers between your colors, because now you're not trying to compare red to blue. You're trying to compare red to white and blue to white. That's actually much easier to do. And a pixel of separation creates, it's a gestalt sort of technique. So it can create enclosure. It can, yeah, there's a bunch of other perceptual things we could talk about. But lines are powerful. And so while we're here, yeah, we can darken the blue, which allows us to darken the red. So this is sort of the new scheme. Now the red text passes, and here's the before and after, and it's an improvement. And hopefully people have thought a little more about design. We did a bunch of studies and stuff of like people using Chartability, blah, 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 because I'm a researcher. Boring. Don't read the papers. You can go look up Chartability. It's actually really useful if you want to get into this sort of thing. There's 49 other heuristics. This was just sort of one of 50. And this is used all over the world. So it's used in policy organizations, governmental groups, and so on. Microsoft uses it. They're actually super supportive of my work. They were part of our original group of participants. Folks at GitHub have been really supportive over the years too. High Charts and Adobe and so on. And Apple's not even on here, which is funny. They're big. You might have heard of them. So the next category I want to talk about is tools for complexity. Okay, so let's say we've got this ideal world where some people build things fast and some people are good at thinking. Well, it turns out thinking people run into really hard problems that aren't easy to solve fast. You need new types of tools for that. An example of this is the humble mouse. Now, I introduced this problem earlier when I showed you the mouse on the screen and wiggled it around, and then I showed you navigation. Turns out this simple single A accessibility standard, which is in Chartability, is like the hardest thing to do. Navigation and interaction. Anything a keyboard or anything a mouse can do. So if you click something in a visualization and it does something like loads data, filters, whatever, you need some way for somebody who uses only a keyboard to be able to do that. If you're ever building anything for yourself that's interactive, try using that interactive thing with a keyboard and you'll curse yourself forever because it's very hard to fix. Actually, that's not true. Some things are very easy to fix. But in data visualization, it can be very hard. And so I set out to make some tools to kind of make this particular problem easier for people. Remember, I'm a tool maker. I'm not just trying to make all visualizations interactive and navigable in the world. I'm thinking about people who make visualizations and they have been building tools for other visualization people. How can I empower them? So discrete and direct navigation do in general face more barriers, but actually this technology that navigates stuff has been around a long time. Screen readers aren't the only thing that uses the keyboard API to navigate. This shown up here is a sip and puff device. This is a quadriplegic person who uses a wheelchair, navigating, interacting, typing, using their computer by breathing into a tube mounted on their desk. Sip and puffs have been around since 1960. This one's called a possum. And actually, they're still used today, and they are still very poorly supported. And it's actually pretty simple. Just to be able to navigate, everyone should be able to do that in all interfaces. So how do you solve this problem? It's tricky. Back in the day, High Charts, a really wonderful group of people, decided we're not just going to give tables that accompany every chart because our charts are interactive. We want people to be able to dive into the data points and navigate around and click stuff. Pretty cool concept. In 2015, they shook the world. 2018, I came along with Visa and copied them, and we really just added more. We really just added more descriptive semantics for screen readers. So if you're navigating the chart elements, it doesn't just say this is an image. It says this is a toggle button. You've selected it, and so on. And then this really great project came along by some lovely folks at MIT, some good friends over there, where they essentially just took this pattern, ran some studies with people, empirically justified our work, which literally means they just work with people with disabilities and proved this is good to do. It's nice to have a paper that just says this is good. We should do it. And then they built a generic tool that anybody could use. So they kind of beat me to the chase, but I still like to talk my own work, which came a year later, a generic tool. Because actually I said, wow, that's a great study you've done, but I think I have a better way of doing this tool. And not to get too into the nitty gritty, but under the hood, they have a hierarchical structure, which actually makes it hard to navigate between parts sometimes in a visualization. So I use a graph structure under the hood. And then I also have very fun demos where I call it a limonstration, where I use even produce. And a makey, it's like you just hook up wires to like whatever you want. And I'm like slapping lemons and navigating charts and stuff to demonstrate it. So remember, you should have some fun with your tools. So how does it work? Yeah, I essentially use the data, the underlying data from a visualization to then create this interactive layer on top of whatever pixels or whatever you use to make the chart and render it. And a graph is nodes and edges. For those of you who aren't like familiar with graph theory or haven't taken like computer sciencey stuff, but a graph is cool because the simple node and edge type of system, this relationship, can build other structures like tables, lists, and hierarchies. So it allows you to create a lot of navigation experiences that are very hard to think about and design otherwise. Also, it allows you to create navigable graphs, which nobody had done before. Even richly navigable maps is a very hard problem. And of course, things like diagrams, which are kind of like graphs, but a little more structured. An example of how this works, so shown here, this is Bokeh. It's a Python visualization library. We got a great grant to do some work with them and add Data Navigator to their stuff. So shown here is the graph. It looks like a line. It's 4 things, one after another. And the chart is on the side. So you're going to see I'm going to navigate into it and through it. And that's it. Seems simple enough. This is really hard, you guys. Nobody does this. That's pixels. And you can now navigate it. And you can't just, you're not just throwing some model at this and it automatically does this. We have the whole team of folks at Bokeh thinking really hard about this. How do we make good experiences? I'm working in tandem also with the folks at Adobe right now. So this is their visualization design system. So the equivalent of like Visa chart components, but it's over at Adobe. And this one is an example of something that's not a list. This is hierarchical. So I was going across groups. Now I'm within a group, but now it's taking advantage of the graph. I'm going across outside of the hierarchy and the tree. And it allows us to do really wild stuff. So animated visualization is already a hard thing to do technically. It's hard to design for. And a lab mate was working on a tool that helps you create animated visualizations. And he was like, can I make this accessible? And I was like, I don't know if it's going to be accessible, but we can make it navigable. Minded up like that Flourish tool earlier. But it turns out what we built was really cool together. So you can navigate into an animation or an animated visualization, and you can go across data points, and it will animate as you go. And this is really cool because a lot of people assume somebody, for example, who uses a screen reader is totally blind. The assumption is somebody who's blind has 0 sight. Blindness is a spectrum. A lot of people who are blind actually have partial sight to some degree. There's a broad spectrum of what that means. Being able to show stuff still while you're navigating is really helpful. Yeah, folks love this. Both people who with disabilities, but also developers think this is neat. And I think it's neat because it's cool. Okay. So that's complexity. Those are hard problems and tools for hard problems. Now, this is tools for possibility. Final category. This is the hardest one. I thought about how do I talk about this because it's just going to be weird stuff. So I have one project I'm going to talk about. And we'll see how this goes. But this really leans into the you should have fun with it. But also, like, if you're developing those neurons and you're growing your brain, this cool thing happens where you start to think really laterally about stuff. You start to think outside of the box is the corny way of phrasing it. But I'll show an example of what that means. So language can't do everything, I'm sorry. LLMs will not save us from all problems, unfortunately. I spoiled the next slide. But turns out when we try and use language to do everything, so if you use an LLM, I love this diagram so much, I'll walk through it. It's a great paper. It's called Homogenization Effects of Large Language Models. What this means, what was that? Such shocking. I shocked someone into noise. So there's yellow circles, there's purple circles. Sorry, I didn't hear that. Yellow circles, purple circles. On the yellow side, they had 3 groups of people and asked them to come up with ideas. And then we show a Venn diagram of overlaps, and it turns out when you're using this particular creative support tool that is not a large language model, your ideas are pretty different from other people's. But when you use a large language model, you still have a diversity of ideas, but it turns out there's more overlap. That means your ideas end up similar to other people's. Large language models, that's the homogenization effect. You're using them, they might seem, so people's perception of their own creativity was higher when using an LLM. I think I'm so creative. That's called local creativity. Globally, though, it turns out you come up with a lot of ideas other people came up with also using the LLM. So that little interaction space is the one that I think is really interesting to think about. Okay, so if language can't do everything, let's think about the perception of language. This is data visualization. I'm gonna ask a question. Those of you who are very fast and brave. Okay, my question number 1, show with fingers. It will be less than 5. So already spoiling, it's gonna be a number between 0 and 5. How many of the words shown are in yellow? That was fast. That was sub quarter of a second. Really good, super fast. How many words are written yellow? Very fast, incorrect answer. I love that. That's awesome. And much slower. Lots of incorrect answers. That's beautiful. Okay, lovely. Okay, some of you got it right. It is slower. When we look at language, we use the language center of our brain, and it's slow. Color doesn't use the language center of our brain. It uses other stuff. Helps our lizard brain dodge enemies and whatnot. So anybody who's really confident want to say at least maybe 1 or 2 things about this that are weird? Actually, a better question is, what's the difference between these 4 sets of data? Wow. We got some lateral thinkers in the room. Thank you. The difference are the numbers. Actually, it turns out the summary statistics for all of these. Oh, I'm getting this again.
The X is the same.
Ooh, I like somebody spot one of them on 4. That's great. So if you run summary statistics, these are actually going to look the same. So if you're a data scientist crunching numbers, if you're not looking at every single piece of data in your data set, you're going to be like, this is the same data. Of course, then it's not the same data. Good job spotting that last one in set 4. That's the weirdo over there. So that's called an outlier in set 4. That is the one that I hope people notice. There's kind of a minor outlier in set 3. The other set 1 and 2 are kind of like nice data sets. And this is from a really great study in 1974, and Anscombe's quartet. Wow, I need more water. I'm tripping over myself. But it just justifies that visualizing things using our visual center is good. Maybe that means language isn't always good for us for understanding stuff. So visualization, data visualization is still great. Okay, so we visualize data to escape language sometimes. So what do people who are blind do? Now this problem gets even harder. Because when you navigate, it's language. Screen readers read out words over and over and over and over and over and over and over. If you're on Wikipedia and you hear the Latin name for cat, that's the circle on the bottom of this big red zigzag path here. And then you're like, ooh, I want to search up at the top for, I don't know, Latin name for dog. You have to navigate 67 times backwards to get to the search bar. So you're gonna have to hear words 67 times while in your brain you're like, a salad day? Feline dog? What was it? It's hard. It's actually really, really, really hard. Movement becomes cognitively expensive when you use a screen reader because it's just language, language, language very fast. Lots of studies on this. So what I'm saying right now isn't like I've discovered something hard about screen readers. People have been working on this for a long time. And actually this is fundamental. It's not related to the screen reader being a problem. It's actually just that auditory processing struggles with dual task. Dual task paradigms is literally, can you keep something in your head while somebody talks to you? We suck at that. We're really bad. You can train yourself to kind of be good, but actually what you end up doing is you selectively listen to the other person. So it's still not very good listening. Keep that in mind if you want to get better at listening. It's like, let go of your thoughts. But when you're interacting with data, this is like a hard problem. I didn't know what to think, what to do about this for quite a while. We do this really awesome thing in DataViz, one of my favorite things called cross filtering. These are linked data sets, linked visualizations with a singular shared data set. Sorry, I think I'm getting a little feedback. If I, hello. If I kill it, it's still a little ringy. Sorry, everyone. So if you filter the top, it will change stuff on the bottom. So filtering this causes some output change down here. If you just like try and navigate like a cross filter with a screen reader, it is super hard to even understand what you're doing and then understand the change. So I thought, okay, well, sound isn't going to help us. Can we think about touch? So people who are blind, especially those who are Braille literate, actually interact with touch all the time. People who are blind interact with touch all the time, but in particular, folks who are blind, who are Braille literate, actually really love using what's called embossed Braille and embossed graphics, which is kind of where you create these raised surfaces on paper. And I was working with somebody with a separate project, and I noticed he was trying to describe, he's a neuroscience engineer, and he was trying to describe something in a research paper to me, and I don't know neuroscience. And he had it printed out in Braille, and he flipped it to about halfway and put his hand in the top part of the paper. He remembered where it was. And then he's like feeling it, he finds it, and then he scans the back, finds the page where the equation he was going to show me improves in this paper. Then he scans, and then he read both at once really quick. And then he found where they felt different, and he said, okay, here's where the equation gets good. And he started talking to me. So he can do dual task, and like also there's this like fuzzy memory storage thing he's doing. There's a lot. And so this made me realize I shouldn't be trying to use language to solve everything. Shouldn't be using sound to solve everything. Let's make a device. So I built this thing called the cross filter, where basically it has two handles that correspond to the visual cross filter. And then while you're interacting in one chart with this filter, you render a tactile graph of output charts. Turns out people love this. We did a study on it. People were like, they straight up just loved it, like huge enjoyment score. They also were way faster at a bunch of data tasks we gave them, and they had way more data queries that they performed and spoke. We asked them to speak their queries out loud while they did the study. Also, the cool thing is if you do something weird, it gives people other weird ideas, which was maybe my favorite part of this study. So they started saying, wait, I can't. So the refreshable tactile display is like $20,000, and they're like, "Wait, can't I just like print out like 1,000 charts?" And then when I filter this one, it just says "Turn to page 742." I'm like, "Yeah, that's really cool. What? We could do that. Like printing 1,000 pages is way cheaper than a $20,000 device. Super good idea." Then somebody else was like, "Ooh, can I just like interact like the sonifications that play with charts? It's really hard to tell where I am. What if it tracks it and I can slide through it?" Yeah, that's also a really good idea. And then they also had ideas for like knobs and other physical devices. So if you're weird, sometimes other people meet your weirdness and it's just beautiful. Okay, so in summary, don't build for evil. I want you to think about the iron mines in your work. Specifically, like there's this graphic of a data center over New York that was shared optimistically by Meta. I think we should think about stuff like that. Maybe not in a positive sense. And then also the chairs. How do our tools kind of shape our brains, shape our creativity? And what are we doing to ourselves when we use these tools? What are we doing to the world? What policies do we want to see? What change do we want to make? We're tool makers. We're powerful. We can influence stuff. A lot of you might be in here in your early career. You might not think you're powerful, but you are. Um, and so when it comes to building for good, don't just think about tools for scale. Help people think. Introduce a little pain in their lives. Think about those hard problems that maybe are difficult to scale. And think of new possibilities too. Thanks.